Hey everybody, this is a clip from a larger video on solving exponential equations, specifically when you cannot get it to be a power equal to a power where the bases are the same. So we end up using logs. In this clip, you're going to get a pretty ugly log equation, so I think it really does include an awful lot of what you're going to encounter. I hope the solution helps you out. Best of luck.
Looking problem, ugliest looking problem that you would face. I want you to take a look at both sides of the equation and notice that we have our variable in the exponent. We've got to get it out. Writing a power base 3 and a power base 2 as powers of the same base will be difficult, so we take the log of both sides. When I take the log of both sides, I want you to notice that I'm taking the log of this whole side. Now we may see a bit of a problem. A common mistake is going to arise, and what it's going to be is that we want to bring that exponent out in front. But I want you to notice that I do not have a single power inside my log. I have 4 times a single power. And so since the exponent x plus 4 is not the exponent on everything inside the log, I can't bring it out in front. Now I'd like to just show you what I would end up getting if I did. You would try telling me that that would be x plus 4 times the log of 4 times 3. And if I were able to do that, then couldn't I go through and just multiply the 4 times the 3 up here? And then you hit the brakes, because we recognize that that would be a bedmass mistake. That you can't do multiplication before you do exponent. And so we can see that all of that green is incorrect. So for us to go through, what we're going to deal with then is a problem that arises in avoiding that green. Now I'm just going to go through and clean that up a little bit. There we go. So on the left side, you'll notice that I do have multiplication on the inside. And I know how to break apart a log if I have multiplication on the inside. I know that I can break that up into the addition of 2 logs. Now, before we jump to the right side, I would like you to notice that on the left side, I have cured my problem. That 3 to the exponent x plus 4 is a single power inside my log. And so we can see the benefit to breaking apart both sides using our properties of logs to get to that. Now, just for uniformity, I may take a look and say, I'm going to bring this exponent down. At the same time, I'm going to bring this exponent down. If you'll take a look at that line, you'll notice that that's like a line in the previous solution. So I would like everybody to pause this solution, finish off the solution, and we'll see if we match up. Okay, welcome back. I'm hoping that our first line was to go through and expand the brackets. We now have this really ugly looking equation with a lot of terms. We now have that equation, and I notice I have an x term here and an x term here. I notice that I have a constant, a constant, a constant, and a constant. So I got a lot of stuff. Well, the first thing I might want to do is get all of my x terms on one side. I would hope that we would be okay to think of our x terms on the left side and factor out the common factor of x, or collect those terms all in one step. So notice my green underlined term on the right side, 3x log 2. For me to get rid of a plus 3x log 2, I need to minus it, and that's why we see the minus in between. On the right side, I already have a log 5. I already have a negative log 2. And now, on the left side, I want to get this log 4 term out of there, which means to get rid of a positive log 4, I need to subtract log 4. And I also want to get rid of this positive 4 log 3, which means I'm going to subtract 4 log 3. Well, I'm almost done. Now I can get that all by itself, so I can see that I'm going to divide out a log 3 minus 3 log 2. But I want you to notice on top, what I finished discussing in that last problem arises right here. I can collect a log 2 and a log 4. And so when I simplify that top, I've got my log 5, and those two green terms can come together to give me one term. And I can't collect that with a log 3, and there's my final expression. So hopefully we got down to the same thing, and everybody matches up, and we're good.